Hello, everyone. Mr. Kesnick, working on doing the podcast here for you for the third week. So the first thing you guys are going to do is working on single-step equations. All right, you're going to be asked to solve for a variable. I'm just copying these images straight out so you're used to what it looks like in Delta Math. Okay, pay attention to whether they're capitalized or not. Remember, lowercase letters, like an A in geometry, was like a side, whereas uppercase A was an area. So the case of the letter matters. So that's taken into account whether the letter's capitalized or not. They're asking you to solve for H. They want you to get this alone. N is attached to it. It's held by multiplication. You undo multiplication by dividing. So you divide by N. Okay? So your answer then is H equals 4 over N. And you're done. Just answer that in Delta Math. Solve the equation for A. D needs to go away. D is positive right now, so you're going to subtract the D from both sides. A equals, typically I would write H minus D. It would not be incorrect. It would be okay if you wrote negative D plus H. I'm not too sure how many of you would want to write it that way. It wouldn't be my preference either, but just letting you know that it is okay to write it that way. I would just go H minus D, just go vertically with it, okay? So in this first one, we saw when you're multiplying by something, you undo it by division. So in this one is, you want to solve for M, you want to make the Q go away. It's held by division, so you're going to multiply both sides by what you want to get rid of. I want to get rid of Q's, uppercase Q, so I'm multiplying both sides by Q. This cancels out, so you have uppercase M is equal to R times Q. The order that you write R times Q doesn't matter, and you don't need to put the times. You could write RQ or QR, that's fine, okay? All right, multi-step ones. What you guys need to pay or watch out for is PEMDAS. I really didn't bring it up in these first ones because you really didn't need to worry about it. They were isolated skills. You're either adding or subtracting, multiplying or dividing. Here, remember when you're solving an equation, you're working up PEMDAS. So you're going to undo adding and subtracting first. You want to solve for B, which is this letter here. Again, this whole thing is a screenshot of what it looks like. Okay. If you need the square root symbol, there's the button for it. That's what it'll look like in Delta Math. They want you to solve for little b. Okay? So the first thing you look at, before you worry about b's in the denominator, is you've got this subtraction here. So I'm going to undo it by adding f to both sides. So now I have d over b is equal to q squared, oops, I was going to go minus plus f. Okay? You want to get rid of, or you want to solve for b on the bottom. One way you guys could do this is think of it as a proportion. A over b, c over d. Is that when you have this, you cross multiply. That's the only time you cross multiply. If I put this over 1, you can see a proportion now. It's b times all of this stuff. And because it's times all that stuff, I'm going to put it in parentheses. And d times 1 is just d. Now, that may seem like I made it really complicated. Don't multiply this inside the parenthesis. It's b times all of this stuff, and I want to solve for b. All of this stuff is held by multiplication, so divide it out. So your answer is, sorry, this is kind of in the way and all over the place, b equals d over q squared plus f. That would be your answer. Okay? You can have it in parentheses if you want. The parentheses that really aren't needed at that point. They are needed originally here at this point, but they're not needed in the final answer. And you would go ahead and type this in. To get the fraction bar, you'd probably write d slash, and when you use the slash for the division symbol, you have to put the parenthesis. If you could write it as a as a horizontal fraction bar, then you don't need the parentheses. But when you use the diagonal, you have to. but there isn't a mechanism here for you to write the fraction with a horizontal bar. So when you do this, you're going to have to put the parentheses there. Why? Because if you don't, d slash q squared plus f, that would mean d over q squared plus f is what that would mean if you didn't have the parentheses. And that's not what you mean. You mean that all of it's in the bottom. Okay, solve for f. So you want to solve for, ooh, look at that. Okay. There's an f here and an f here, so you need to get them on the same side. So I'm going to add this to the other side by adding uppercase GF to both sides. That could be GF. So I've got RF plus, oops, GF is equal to H. You want to solve for f. There's an f in common. I'm going to factor that f out and leave you r plus g is equal to h. Okay? Sorry, it's a pretty poor g. I factored it out as if it's distributing in reverse. If I distributed this into the parentheses, if I distributed this in, I'd get what I started with. Again, that's supposed to be a g. Looks like a 6 now. Oh dear. Okay. In a previous problem, I said when you had a bunch of stuff here, you would just divide it out. This thing, you would divide out all at once. That's what's going to happen here. All of this is being held to the f by multiplication, so I'm just going to divide both sides by r plus g. Okay, so your answer is f equals h over r plus g. And the same thing I told you about when you do the fraction symbol, you need to put a parenthesis there. Okay. All right, solve the equation for a, for this little a. All right, this is back to PEMDAS. Oops. You're going to undo any adding and subtracting first as you work up this. So you're subtracting 8, so start by adding 8. So you have 1/5 RA is equal to G cubed plus 8. Now you want to solve for A. You're multiplying by a 1/5. What would undo that? Multiplying each side by 5. And it's the whole side by 5. So this would cancel out, and you'll have to RA is equal to, you have an option to leave it outside, or you can distribute it in. I'm just going to leave it outside for the time being, just to let you see what's going to be there. G cubed plus 8 times 5. And if y'all wanted to write that in front, 5G cubed plus 8, that's fine too. Okay. I want to solve for A, so I need to divide by R, because it's held by multiplication. So your final answer is A is equal to, parenthesis, if I had just left it here, G cubed plus 8 times 5, or parenthesis, just the 5, over R. When you go to type this in to Delta Math, you can type it just as you see it. Parenthesis, G, sorry, it looks like a 6, cubed plus 8, parenthesis, 5, divided by, with the diagonal bar, R. Or if you want to put it in front, it would be the same thing, all right? If you guys wanted to distribute it in, then you'd have 5G cubed plus 40, and it would all be over the R. And you need to have a parenthesis around that when you do the diagonal fraction bar. Okay? Let's see. All right, you want to solve for A. So we're back to PEMDAS, but remember, this square root symbol is considered to be an exponent, or for all intents and purposes, you could think of it as a parenthesis too. I'll explain more of that as we move on through the year. Before I can touch the multiplying or the addition, I need to make this symbol go away. And what undoes a square root is a square. So I'm going to square both sides. 5a plus h is equal to q squared. You want to solve for a, So now you're just back at the bottom of PEMDAS working up. Subtract the h. 5a is equal to q squared, minus h, and then divide by 5, and you're going to divide the whole thing by 5. When you go to type that in Delta Math, there's no currently any parenthesis there, but you're going to need to write one. You're going to need to go q squared minus h in a parenthesis, divide 5. If you don't, the only thing that's going to be divided by 5 is the h, if you don't put the parentheses. Okay? All right, solve the following equation for a. You may assume all variables are positive, so you don't need any plus and minuses. Okay, real quick what that is. If you had x squared is equal to 25, and y'all put a square root symbol on the page to do that, normally you would write plus or minus 5. They're saying ignore this. Ignore the plus and minus. Okay? All right, you want to solve for big A. There it is right there. PEMDAS. Undo any adding and subtracting first, then multiplying or dividing. So I have to undo adding and subtracting. The m squared is held there by subtraction, so I'm going to add m squared to both sides. So I have n plus m squared is equal to h a squared. Again, I want to solve for a squared. This is held by multiplication, so I'm going to divide it out. So I have n plus m squared over h is equal to a squared. Now you ask yourself, what will undo a square? Okay, a square root. So I'm going to square root the right. I'm also going to square root the left. So your final answer is n plus m squared over h is equal to a. Okay, so when you go to type this in Delta Math, they give you the square root symbol, so you'd hit that first. I would personally put a parenthesis next to grab the n plus m squared, close the parenthesis, divide h. Now the risk here is that they might, depending on, if you don't see this square root extend out over it in Delta Math, then I would leave the parentheses off. If you do see it extend, then I would leave it. And I think I said that the right way. The concern is, will it stop the square root when you close that parenthesis and think you're typing in this? Okay, so just be aware of what that square root is doing. Okay, you can always put a double square root there if you wanted to make it all stay under the square root. Okay. Hopefully that wasn't too much information. I think that's the last slide. Let me look. I know there were a lot of little nuances. Yep, that's the last slide. Thank you for your time. Please come into touch points if I can help.